What is up, everybody? I hope you're having a good day, because today is going to be a fantastic day. That's going to teach you C++. This is the code we did in class with Prof. or Dr. Chivaya. He was using C++, but that is not a problem because a valid C is a valid C++ program. But I know you guys are used to your usual C++. You guys love C++, so I'm just going to use C++. The code we are going to show you today is going to be able to run on code blocks. It is going to be able to run on Visual Studio Code, in C Lion. This code will run everywhere, and it just uses C++. That's going to teach you C++. So the first thing I want to discuss with you today is the concept of pointers. I think we didn't touch a lot of those in class. Pointers. What is a pointer? A pointer is simply a variable that points to the memory address of another variable. Say, for example, if we have int n equals to 5 and we want to create another variable that points to the memory address of n, what we do is that we say int star ptr is equals to, and then we use that symbol. I don't know, you know the symbol, right? That's n, the symbol, and then we just says n. This code here creates an integer n and initialize it a value of 5, and then it creates a pointer ptr which points to the memory address of n. Okay, so I can use ptr to change the value. Okay, let me say 6 of n. Now if I go see out, where does it please? See out n, the value of n has changed now to 6. Okay, we have changed the value of n through a pointer. That is basically what a pointer is. That is the simplest explanation of a pointer. So let's go look at our C++ code. Okay, we're just gonna go straight and look at our C++ code. The code starts by creating a node structure. We are used to structures. We did structures in first semester. The code creates a structure which will store your name, student number, and age, and then the structure has a pointer which will point to the previous node. So we were doing this as a stack, but to me it looks like a singly linked list. So the pointer looks like this. It is a structure. It stores your name, student number, age. This is a structure, but okay, I'm gonna use this to represent the structure, and for node I'm just gonna use a smaller square. So this is the structure of our node, right? Our node will have name, student number, and age, and a pointer which will point to the previous node. Okay, we have explained the uses of pointer in the first example. So this here creates a global pointer new node. Okay, this code creates a global pointer new node and previous node. Obviously previous node will point to the, okay, in our example we are going to use previous node to point to the last thing added in our linked list or our stack. Okay, prev node will be the last thing added to our stack, and the new node, we're just gonna use new node to create new nodes, because we don't want to be creating, we can just be creating new nodes here inside the for loop, but I don't want to do that multiple times. So we create this global new node, and then I'm just gonna loop 2 times to just create new nodes, new student nodes. Okay, let's go into the code. This code here, new node equals to new students, will create a node of type students. If I may say that, it will create a node that will hold these things here, that will hold name, student number, and age. Okay, this is what basically what this code here does. It creates a node that will hold those things, and then here you're just populating that node. Let's say the node looks like this. It is the first node, so you're here, you are just populating that new node, and then because that node have a previous address which will point to the address of the previous node. So if here we have already initialized previous node, which I said is will always be the previous address will point to the address of the previous node, and then prev node will be the pointer to our last thing we added on the stack. Okay, so this new node created a node, we populated the node, and then because it's a node, the new node previous address, we want to point it to the address of the previous node. But because this node here that we created now there's no previous anything, it is the first one, so we just it will be it's okay, let's say name is K, its previous address pointer will be pointing to null ptr, null pointer, because here it's already null, and then we give it the title prev node. This node will be given the title prev node. Because the loop is running 2 times, it will go again and create a new node. Okay, a new node the same way to create a new node, and then we're going to populate that node. And let's say the initial of this person is J, this person is Jane, and then we'll populate the Jane student number and Jane's age, and then the previous address of Jane will be the previous node. Remember, previous node is this node, so the previous address of Jane will be pointing to this node here. Prev node will be pointing to, it will link itself with prev node here, right? And then this prev node will be stripped of the title prev node, and this one will become prev node. Now this node here, this one will be stripped of the title prev node, and this one will become prev node because it is the last element to be added in our stack or linked list. Okay, I hope this is simple. So let me just explain the code to transverse. Maybe it will make sense. We're still using the same global pointer new node, and then we'll initialize it prev node, which will be this node, and then we say while new node, this node that we initialize to this is not null ptr, we go on and print new node. We go print the name, the student number, and the age, and then after we're done we say new node, this node, it will be this node initially, and then we say it is equal to previous address, which will be the previous node, which will come to this node, do the same thing, this is the same thing of printing name, student number, and age. But now when it goes to, because we are here now, when it says new node is equals to prev address, and then prev address is null, the loop will break, will not run because it will be equals to null ptr. The loop is running as long as the address of the node is not null ptr, because here it will be null ptr. The code will stop, and then you would have transversed through your singly linked list or your stack, printing everything that is in the stack. So basically what the code is doing, it creates a node, gives it a title prev node if it is the first node to be added. Okay, let's say it's K, and then its prev address will be null if it's the first one, because there's no previous node after that one. So when we go on to create a second node, let's say J, its prev address, because it will point to prev node, which is this one, and strip this one of its prev node name, and then gives itself prev node, because prev node is the last node to be added to the stack. I hope I was clear. If I'm not, just leave a comment. I will do another video which I will be slow and I will explain everything in detail, but I think this was a very intuitive way of explaining this. Thank you.